We have already discussed ionic bonding in detail in our earlier video, and we had also seen some examples. So in this video, we will learn some topical questions of ionic bonding, which includes the past paper questions. So let's start with some MCQs, where the first question here is, when sodium chloride is formed from its elements, that is sodium and chlorine, each chlorine atom dash 1 dash. Now which words correctly complete gap 1 and 2? To fill in these gaps, first let's understand how is sodium chloride formed. Now, as we have already discussed, that in ionic bonds, that is in ionic compounds, the metal atom, that is sodium in this case, will lose electron, and chlorine, that is non-metal atom, will gain electron. So here if we are talking about chlorine atom, it should gain 1 electron. So looking at this option of A, B, C and D, loses gets cancelled on its own. So we are left with option A and B. Out of that, now if option 1 is gains, look at the option 2. It says electron or proton. Now obviously electron are gained. So our correct option is A. So let's tick our option A. Now let's move to the second question, which is again an MCQ. It says, which two elements react together to form an ionic compound? Now here some options are given, where element W has an electronic configuration of 2, 4, element X has an electronic configuration of 2 and 8, element Y with the electronic configuration of 2, 8, 1, Z with 2, 8, 7. Now as we know, ionic compounds are formed with a metal element and a non-metal element. Now we also know that the metal elements have just 1, 2 or 3 electrons in their outer shell, and non-metals should have the electronic structure with the outer shell as 5, 6 or 7 electrons, so that it can gain electrons and the metal atoms can lose these electrons. Now, so looking at these structures of these elements, we can see here the electronic structure is 2 and 4. So now for W, we can understand that the element W, rather than gaining or losing electron, it will tend to share the electrons. Now if you look at the next element X, it has the outer shell electron 8, that is a noble gas configuration which will not react. So you are left with the option Y and Z. So our correct option is C with Y and Z. Let's start with the third question, where the third question says the electronic structures of atoms P and Q are shown. Now you can see here the structure of atom P and atom Q. Now the question says P and Q reacts to form an ionic compound. What is the formula of this compound? So let's have a look at the structure of P and Q. The element P have an electronic structure of 2, 8 and 1, because as we can see that the inner shells with 2 and 8 electrons are full, and the third shell have only 1 electron. And for the structure of Q, we can see that it has the structure of 2 and 6 because it has 6 outer shell electrons. Now if you look at the outer shell electrons, we can understand that P has a tendency to lose 1 electron, so forming an ion of P with +1 charge, and Q has a tendency to gain 2 electrons to get a charge of -2. So if you look at this structure, this arrangement, we can make out that Q needs to gain 2 electrons from P. Now P has a tendency to lose only 1 electron. That clearly shows that 2 P atoms are needed. So the formula should be P2Q. We can use another method of finding out the formula is that we can crisscross the valency. That is, 2 can be brought down with P and 1 can be brought down to the Q. So in that case also we can get the same formula. So if you look at the options, the P to Q formula is with the option B. So our correct answer is B. Let's move on to the fourth MCQ, which says the diagrams shows the electron arrangement in the atoms of 4 elements. Which element does not form a covalent bond? That shows that this element should either form an ionic bond or should form a metallic bond. So in that case, both the cases, we need at least one metal, because we know that the ionic bond is formed between a metal and a non-metal element, and even the metallic bond is formed with the metal elements itself. So we should have at least one metal. And as we know that the metal element should have the outer shell electrons as either 1, 2 or 3. So looking at the structures of the elements A, B, C and D, let's have a look at the outer shell electrons only. Now A have the outer shell electron 1, B has the outer shell electrons 2 plus 2, 4. C has the outer shell electron 2 plus 2, 4 plus 2, 6 and 1, 7, and D has the outer shell electrons as 2 plus 2, 4, 5 and 6. So from this we can make out that our element which does not form a covalent bond should have the outer shell electron 1, 2 or 3. In that case, our correct answer should be 1 with the outer shell electron 1. Now let's move on with our fifth MCQ, which says rubidium is in group 1 of the periodic table and bromine is in group 7. Rubidium reacts with bromine to form an ionic compound. Which row shows the electron change taking place for rubidium and the correct formula of the rubidium ion? Now as the question asked is about rubidium and rubidium ion, so let's have a look at the detail of rubidium atom. It says rubidium is in group 1. Now from this we can make out that the rubidium atom has an outer shell electron which is just 1 electron because it is in group 1. Now as we know that rubidium with electron group 1, that is 1 electron, is in the metal side, that is on the left hand side of the periodic table, and it has just the tendency to lose this electron and not to gain the electrons. So with this, our option A and option B gets cancelled out. Now we are left with option C and D, which says electron lost. Now let's have a look at the second column, which gives us the formula of rubidium plus 1 charge and rubidium minus 1 charge. Now as we know that if the electron is lost, then rubidium is going to get the positive charge. So our correct option is this, which leaves us with the correct answer C. Now we have discussed few MCQ questions of this topic. Now let's start with some subjective questions also for ionic bonding. Let's start with the first question, which says, following is a list of electron distribution of atoms of unknown elements, where the list of all the elements and its electronic distribution is given. Now it says that element C and F can form an ionic compound. Now let's have a look at the element C with an outer shell electron of 2 and element F with an outer shell electron of 7. Now as we know that in ionic compound we just need to deal with the outer shell electrons only. So we are not having a look at the other electrons in the inner shells. So C has the outer shell electron 2 and F has an outer shell electron as 7. Now let's have a look at the further part of the question, which says that Elements C and F can form ionic compound. Now draw a diagram that shows the formula of this compound, the charges on the ions, and the arrangement of the valency electrons around the negative ion. Now we can use some symbols also to represent these elements, that is, use the not symbol for electrons of atom C and a cross symbol for the electrons of atom F. Let's start with the first part of this question, that is forming the formula of this compound. Now as C has the outer shell electron 2, so C has the valency of 2, and as F has 7 electrons, so it can get a charge of -1 because it can gain 1 electron to become full outer shell. So if you crisscross the charge or the valency, we get the formula as CF2. So this shows that we need 1 atom of element C and 2 atoms of element F to form this compound. So let's start with the presentation of C and F of this diagram. If we draw the atom C with an outer shell electrons, we know that we have to use this symbol to present its electrons. So as C has 2 electrons, let's draw 2 electrons for C. And for F, we need to draw 7 electrons. So for drawing the 7 electrons, we need to use the cross symbol. And so we are done with the F atom with 7 electrons. But as we have seen that we need to use 2 F atoms. So we need to draw one more atom of F again with 7 electrons. As you can see that I am drawing the electrons in pairs so that it is easy to count. Now what happens is that one of the electron of C gets transferred to F and the second electron gets transferred to the other atom of the F. Now this leaves the compound with element C with charge +2. Let's draw that in the bracket, and then it says that we need to draw the valency electrons around the negative ion. Now as we know that F is the negative ion which has gained the electrons, so we need to draw 2 F atoms with its outer shell electrons showing the negative charge. Now let's first draw its 7 electrons of the F. So this is done with the first atom, but as we know that one of the atom of C has transferred to F, which has to be represented by dot, and this gives the charge of -1 to the first atom. Now same goes with the second atom also, where we need to draw these 7 electrons again for the F atom and one of the electron from C, which again gives a charge of -1 to the F atom. So here we complete with our diagrammatic presentation where the question had asked us to draw the diagram, and as we can see that it carries 3 marks. So now each of the option of the question, that is the formula, the charges on the ion and the correct valence electrons carries 1 mark each. So if you fulfill all these 3 criteria correctly, you get 1 mark for each of it. Now let's see the next part of this question, which says predict 2 properties of this compound. This compound in the sense ionic compound. Now as we know that this ionic compound is formed with a strong electrostatic force between the oppositely charged ions. So it needs very high temperature to break this bond. So that's the reason that all the ionic compounds have very high melting and boiling points. This is one of the property of all the ionic compounds. Now it says two properties. So second property can be that is this ionic compound is soluble in water, which is a polar solvent. So says it is soluble in water. If you want to write more than two properties, or if you want to know, let's discuss one more property, that is it conducts electricity. It conducts electricity, that is, it is a good conductor of electricity, but only in molten form or aqueous form, that is in the dissolved form. So out of these three properties, you can write any two properties to gain 2 marks. Now let's have a look at the second question, which says the structure of an element or compound determines its physical properties. The scandium fluoride and silicon oxide have giant structures. Scandium fluoride is an ionic compound. Now it also says that the valency of scandium is 3, that is, it has 3 electrons in its outer shell. Now draw a diagram which shows again the formula of the compound, charges on the ions, and the arrangement of valency electrons around the negative ion. And again we have symbols, that is cross to represent the electrons of scandium atom and dots to represent the electron from fluorine atom. Now let's make the formula of this compound first. Now as it's given in the question that scandium has the valency of 3, that is, it loses 3 electrons, and as we know that fluorine is a group 7 element, so it will have a charge of -1. So if we make a formula by crisscrossing the valency, we have scandium, that is SCF3. So to represent our diagram, we will need one scandium atom with 3 electrons in its outer shell, which can be represented by crosses. So we are drawing 3 cross, plus we need to have 3 fluorine atoms. So let's start with 3 fluorine atoms with the outer shell electrons as 7, which has to be presented by dots. So we have drawn 7 electrons in the form of dots for the first atom of fluorine, and here goes the same for the second atom also. And now let's draw for the third atom again with the same process, presenting the dots to draw the 7 electrons. Now this 1 electron will go to the fluorine atom each. So we can draw such arrows. Now this is presented, but we need also to show the charges on the ions. So scandium gets the charge of +3, and we also need to show the valency electrons on the negative ion. So let's draw all the 3 fluorine atoms with the negative charge. The negative charge of each fluorine atom should be -1, as we know that it has gained 1 electron each. So let's draw the valency electrons for each of the fluorine with 7 electrons of its own and 1 cross presenting the 1 electron from scandium, giving it the charge of -1. The same can be drawn for each of the fluorine atom, again showing that it has 7 electrons in the form of dots and 1 electron in the form of cross from scandium. Starting with the third atom, we have again the same process, each with the charge -1. And as this question also carries 3 marks, so here we go. The 3 marks were 1 mark each for the formula, 2nd mark for the charges on the ions, which we have already presented, and the arrangement of the valency electrons on the negative ion, which again we have shown on each of the 3 fluorine atoms. We also have a second part of this question which asks that the melting point of scandium fluoride is 1552 degrees Celsius, which is very high. Explain why scandium fluoride has such a high melting point. Now, as we know that there is a very strong electrostatic force of attraction between the scandium and the fluoride ion, and all these ionic compounds, that is the scandium fluoride ionic compounds, have a giant lattice structure. As we know that all the ionic compounds have giant lattice structure, so due to this 3-dimensional giant lattice structure, the scandium fluoride will have a high melting point. So here goes with one reason which will give you 1 mark. Let's start with the third subjective question, which says lithium reacts with nitrogen to form the ionic compound lithium nitride. First part says state the formula of lithium ion. Now, as we know, lithium is in group 1 of periodic table, so it should have a charge of +1. And deduce the formula of the nitride ion. Now, as we know that nitrogen is in group 5, so it needs to gain 3 more electrons to gain the outer shell full. So its charge, that is the formula of nitride ion, should be N-3 as it gains 3 electrons to get the charge -3. Now, draw a diagram that shows the formula of this compound, charges on the ions, the arrangement of valence electrons around the negative ion, as we have discussed in the earlier questions also. Now, let's make out the formula of this compound first, that is lithium have a charge of +1 and nitrogen with -3. If you crisscross the charge, now in this case we get Li3n. That is, we using 3 lithium atoms and 1 nitrogen atom. So let's start by drawing the 3 lithium atoms. So let's start by drawing 3 lithium atoms, where we need to draw only the outer shell electron. Let's represent the electron of lithium with a cross. So we need to draw 3 lithium atoms with 1 electron in its outer shell each. So here we go with the 3 lithium atoms plus 1 nitrogen atom. The electrons of nitrogen can be presented by dots. And as we know, it is in group 5, so we need to draw 5 electrons on the outer shell of nitrogen. Now, let's show the transfer of electrons of lithium by arrows. So, one arrow going towards nitrogen from each of the lithium atom, which will be presented with 3 lithium atoms with +1 charge each. We are writing 3, which represents the 3 lithium ions, and 1 nitrogen ion, where we need to show the outer shell electrons with 5 electrons of nitrogen of its own and 3 electrons from the lithium atom, which will give the charge -3 to nitrogen. And for this, we gain 3 marks. Let's start with the fourth question of this topic, which says, strontium oxide is an ionic compound. Draw a diagram which shows its formula, the charges on the ions, and again the arrangement of valency electrons around the negative ion. The electronic distribution of strontium atom is 2, 8, 18, 8, 2, which shows that it can lose these 2 electrons from the outer shell. Now we need to use dots to represent the electrons of strontium atom and cross to represent the electrons of oxygen atom. So let's start with the formula of this compound first. So strontium has a charge of +2 in this case, and it says oxygen, so oxide has a charge of -2. Now if we crisscross the valency, both the place we get 2. So simplifying the formula, we get SrO. So let's start by drawing the atom of strontium with the valence electrons of 2, which can be presented by dots, and an oxygen atom. Now we know that oxygen has 6 electrons in its outer shell because it is in group 6. So we need to draw 6 electrons in the form of crosses. Now we can show the transfer of each of the atom of strontium, each of the electron of strontium by an arrow, and then finally we can write strontium with +2 charge and an oxygen atom with its outer shell electrons full now with 8 electrons, out of which 6 electrons are its own and 2 electrons in the form of dots from strontium, which will give it the charge of -2. So here, such a diagram can gain us 3 marks. So in this video, we have discussed 5 MCQs and 4 subjective questions where we have learned how to draw the diagrams presenting the ionic compounds, showing its formula, the charge of the elements, and the valency electrons on the negative ions. And we have also discussed some properties of these ionic compounds and some few more points in the MCQs. You can also follow the link given in description to get the PDF of these questions in the form of worksheets. So here you can also watch another video where the ionic compounds are discussed in detail with few more examples.